key part of that.
Now, this ESA suite of instruments is actually going to look at the origin of the space weather around the sun?
So we don't understand how these particles get accelerated up to half the speed of light. We see them here at Earth, but the signatures from where they're coming from, where in the sun, when they're exactly coming, is all smeared out as they travel 93 million miles between the sun and the Earth. By being really close, we're going to be able to identify what parts of the sun these particles are directly coming from and exactly when they are, so we can use images then to look at the sun and say, oh, that's what's happening there, and understand the very origin of these solar energetic particles.
Now, Parker Solar Probe is going to be looking at 3 questions total that they're trying to find out information about the sun. Now, your suite of instruments will cover 1 question, and when we come back in about 15 or 20 minutes, we're going to talk to Dr. Eric Christian about the other 2 questions that Parker Solar Probe will look at during this mission. Marie, back to you.
All right, thanks, Franklin. We look forward to that. Let's check in now with Josh and Mick in the Mission Director Center for an update and a closer look at the Delta IV Heavy, one of the world's most powerful rockets. Guys?
Thank you, Marie. I'm Josh, and I'm joined by Mick Woltman from the NASA's
Josh.
Launch Services Program. And Mick, tonight's launch is on the Delta IV Heavy with the additional 3rd stage added onto it. Can you tell me a little bit about the Delta IV?
Yeah, absolutely, Josh. Due to the extremely high energy required for this mission, the Delta IV Heavy launch vehicle was chosen to put Parker Solar Probe into its trajectory. The launch vehicle is unique in that it has 3 first stages common core boosters that are made up of hydrogen fuel loads. Each of them has an RS-68A engine, which provides that initial thrust to get out of Earth's atmosphere. A Delta cryogenic second stage with an RL-10B engine is used to achieve the intermediate escape orbit once it's in space. And a unique feature of the Delta IV Heavy that you mentioned is the solid fuel third stage provided by Northrop Grumman Innovation Systems called the Star 48BV. It's a vectorable third stage, and that will provide the final push for Parker Solar Probe on its trajectory towards the sun. Of course, during ascent, we want to protect Parker Solar Probe, so it's inside of a 63-foot bisector composite fairing that you see on top of the Delta IV there. And all of these key features play an important role in getting Parker Solar Probe on its way to the sun.
So it takes a lot of people to get a rocket like this off. Members of NASA, United Launch Alliance, the U.S. Air Force, Northrop Grumman, and more. Can you tell me a little about the partnership that it takes to get this done?
Absolutely. It is a team effort all the way around to get a mission this far and prepared for launch. Mission teams working around the country built, tested, and prepared the rocket, the spacecraft, ahead of launch this morning. This included teams from United Launch Alliance in Denver, Colorado, and in their production facility at Decatur, Alabama, NASA's Goddard Space Flight Center in Greenbelt, Maryland, Johns Hopkins Applied Physics Lab in Laurel, Maryland, and the team right here in Florida. We had a spacecraft team processing Parker Solar Probe over in Astrotech in Titusville, Florida. And of course, those folks here, the launch teams at Cape Canaveral Air Force Station in the Mission Director Center and the Delta Operations Center.
And that's a live shot there inside Hangar AE, and now inside the Delta Operations Center, where NASA launch manager Omar Baez and the ULA launch director Lou Mangieri are working with teams to launch the Delta IV Heavy that you see on your screen there, which our launch time is now targeted for 3:53 a.m. So Mick and I will continue to monitor the countdown here in the Mission Director Center, and we'll go back to Marie for more about the NASA's Parker Solar Probe. Marie?
All right, thanks, guys. Tori is standing by live now at one of our launch viewing areas with one of NASA's senior leaders, Dr. Thomas Zurbuchen. Tori?
Thanks, Marie. Dr. Zurbuchen, you lead NASA's Science Mission Directorate. Tell us about the significance of this mission and what it means and why we need to study the sun up close.
This is one of our strategically important missions and the core mission in the heliophysics program, which is one of the 4 disciplines we're studying. It's so important because of 2 reasons. First of all, it's a basic astrophysics question, is how stars heat their atmospheres, their corona, and especially our star, the most important star in the whole universe, which is ours, how it does that. Just by itself, that's a really worthwhile question and it's worthy of studying. But it's also important because of space weather. Namely that this star, that corona, is immersing us here at Earth and our astronauts, and is part of the hazards of space, and we want to learn how to predict that because it affects our lives and our technological infrastructure, both in space and on the ground.
Absolutely. So I understand that this is the very first mission in which NASA named a spacecraft after a living person, Dr. Eugene Parker. And I also understand that you were the one who had the opportunity to make that phone call. So tell us what that means to you and why it was so important to name this mission after him.
So first of all, there's only one name that fits on that mission. It's the name of the pioneer that started it all. And frankly, I figured out with my team that there are 35 missions in our entire portfolio that studied the kind of things that Gene Parker predicted or studied during his scientific lifetime. And so he's just an incredible hero of our science community. And it was really exciting. You know, I knew Gene from being a young scientist and getting to know him, admiring him, and it was really cool to call him up and kind of surprise him a little bit. I remember it's like, first, it's like, I explained who I am. It's like, I met you. It's like, okay, like, would you be okay if we named a mission after you? It's like, I guess so. It's like, first person who ever have been asked that kind of question. So it's just really cool to call.
What an incredible opportunity.
Yeah.
So Dr. Parker is going to be here with us today. I mean, what are you thinking about the fact that you are about to watch this launch right alongside him?
I think it's just absolutely incredible for me also. It's incredible for him and his family. I'm so glad his family is here too, but it's incredible for me just because it's a touching moment, right? It's one of those, life is all about these big arcs. And, sometimes you just see them, like how over a lifetime things come together and create these amazing stories, kind of these leaps going forward. I'm just so glad to be here with him.
Well, thank you for joining us. And Marie, with that, we'll go back to you.
All right, thanks, Tori. Discovering why the sun's outer atmosphere is so much hotter than its surface is a mystery that dates back almost 150 years, and it remains one of the greatest unanswered questions in astrophysics. Here's a look at how far the scientific community has come.
The sun's core is the hottest part of the sun, but our star's temperature doesn't behave as you might expect. The core is roughly 27 million degrees Fahrenheit and 10 times more dense than gold. As you move outward, the layers of the sun become cooler and less dense. Something unusual, however, occurs when you reach the outermost layer. While the surface is around 10,000 degrees Fahrenheit, the corona, the sun's outer atmosphere, is several hundred times hotter. That's the opposite of what happens with a fire. When it gets cooler, the farther away you get. Scientists call this the coronal heating problem, and evidence for this was first uncovered during an eclipse in the 1800s. The corona is usually hard to see. It's too dim to be seen next to the sun's bright body, but it can be seen with the naked eye when the moon blocks the sun during a total solar eclipse. To understand how this mystery was discovered, it helps to know how scientists started studying the chemical properties of materials on Earth. In the early 1800s, instruments named spectroscopes were invented to identify materials that emit light when heated. Light enters the spectroscope and is filtered through a tiny hole to isolate a single area. It then bounces off a special grating that disperses light into its different wavelengths. While sunlight contains every wavelength, scientists discovered that every chemical element and compound contains a unique pattern of wavelengths that allows scientists to determine the composition of light sources. It wasn't long before astronomers started extracting information from the light of distant stellar objects. In 1869, two scientists independently decided to point a spectroscope toward the corona during a total solar eclipse. As the sun's light disappeared, the pattern of wavelengths changed. They saw something they had never seen before. A bright green line that did not relate to any element found on Earth. For a short while, scientists named it coronium. It wasn't until 70 years later that a Swedish scientist discovered that these lines were the result of elements such as iron being stripped of its electrons. Every element has a specific number of electrons surrounding the nucleus. As each electron is removed, more energy is needed to remove the next one. The green line shows that iron has been stripped of 13 of its 26 electrons, indicating that the corona needed to be millions of degrees, counterintuitively far hotter than the sun's surface. Scientists have since proposed a variety of theories for what mechanisms could be adding that extra heat into the atmosphere. One theory suggests that small waves in the sun's surface pushes particles and heat into the atmosphere, a bit like how ocean waves push surfers. Another theory suggests small bomb-like explosions from the realignment of the sun's magnetic field create heat. Many scientists think it may be a mix of both. We've studied the corona from Earth during many eclipses, but to solve our star's biggest mystery, we have to make direct observations from the region itself.
We've had some stormy weather these last few days here at the Cape, but it's been pretty clear overnight so far. Let's check in with Josh and Mick in the Mission Director Center for a weather update. Guys?
Thank you, Marie. We are just a few moments out from receiving a weather briefing from the 45th Space Wing. Our launch weather office tonight will give us our final weather briefing for the launch countdown, which launch teams need to know. But when we're also a little bit out from entering a hold, and Mick, can you tell me a little bit about the hold?
Yeah, the T-4 hold that's coming up is the last opportunity for the team to take a look at the vehicle, all aspects of their sensors and data, everything that's going on with the Delta IV launch vehicle this evening to make sure they're ready to enter the count. They've finished up their cryogenic loading, working on finishing that up, going into topping and maintaining of the first and second stage, getting ready to cycle vent valves and test out those areas of the first and second stage. So this hold will give them the chance to just kind of do one last look of the vehicle and verify that everything is ready and proceeding forward for a launch early this morning.
So while we wait for the hold, which we'll bring to you live, can you tell us a little bit about the U.S. Air Force and other things they do? So not only do they look at weather, they also look at what's called COLAs, or collision avoidance. And we heard earlier in the countdown that there are no COLAs for the T0 time or the launch window. But can you tell us why we look at that and about the COLA process?
Yeah, absolutely. The launch window tonight, as we mentioned, is 65 minutes. We've used up some of that already, so we have 45 minutes left in the window. And the U.S. Air Force performs a COLA, or collision avoidance analysis. One of the considerations they have to do in analyzing is for objects in space. For example, there might be other satellites that are around Earth that could be in the flight path of the Delta IV Heavy tonight once we launch. So as we look at this analysis, as you said, there are no cutouts or no COLAs for this evening in the launch window for the teams that they have to be aware of. So they'll continue to process forward with this 45-minute window. One of the interesting things about it is they actually start the COLA analysis several days before launch and then provide the last report up to the launch managers on launch day and get ready to help determine the T0 for today's launch.
And it sounds like we're just about to tie into this weather briefing.
Standing by.
This RCN Weather Conference Net 8, indicate ready to proceed. LD.
LD.
NLM.
NLM.
AFLD.
AFLD.
And we'll proceed.
This is Yellow. There's no clouds affecting our area and not expecting to have anything significant affect our area in the next 30 minutes. Looking at our constraints, we're going all constraints and not a concern for any space weather as well. Currently now we have just a 5% chance of violating launch constraints. This concludes the weather briefing unless there are any questions.
Indicate questions or acknowledge. LD.
LD.
NLM.
NLM, no questions.
AFLD.
AFLD.
This concludes the weather brief. Thank you, Evo.
Hello out.
And that was the weather briefing that you just heard, short and sweet, which means we have good weather for tonight. As you can see on your screen, the Delta IV Heavy there. No clouds that we're concerned with today. Earlier in the count, we were a little bit worse off, but we've gotten better, so no clouds to worry about. We're go on all constraints. That probability of violation, which is the POV number you see there, is 5%, meaning that we're 95% go. The winds are about 5 knots out of the west, and temperature sitting at about 78, 79 degrees, so no concerns for us tonight, which is a really good thing. And so that's the Delta IV that you see on your screen there with the additional third stage. And we're now at T-minus 8 minutes, 20 seconds and counting. And for that, we'll go back to Marie Lewis for more information.
All right, thanks, Josh. Parker Solar Probe will set off to soak up the sun in about 28 minutes, but it's already had quite the journey. Here's a look at the months of work that led to this moment. For those of you just joining us, welcome to our live coverage of the Parker Solar Probe mission to kiss the sun and unlock its mysteries. Parker Solar Probe is targeted to launch at 3:53 this morning Eastern Time from Launch Complex 37 at Cape Canaveral Air Force Station in Florida. The launch window will be open for 65 minutes. Parker will take off on a United Launch Alliance Delta IV Heavy rocket, speeding up to 430,000 miles per hour in orbit. That's fast enough to get from Philadelphia to Washington, D.C. in 1 second. It will travel 7 times closer to the sun than any spacecraft before. Parker will help us understand how the sun affects weather in space. And why is that important? Well, first, a little background. Parker Solar Probe is named after Dr. Eugene Parker, a physicist who figured out 60 years ago that our star actually has its own wind and storms, and they can spread far into space. This space weather can disrupt communication signals from our satellites and even cause power outages. Besides impacts here on the ground, we also need to understand solar wind to help us explore deeper into space. Just as ocean explorers need to understand currents, NASA needs to understand space weather to help us send astronauts to the Moon, Mars, and other distant destinations. To help us understand more about this space weather, let's go over to Tori with a live guest to help explain. Tori?
Thanks, Marie. Nikki, let's talk space weather. Help us understand Dr. Parker's theory of the solar wind.
So a lot of people get very excited about big space weather events when we have coronal mass ejections and flares and storms. But what a lot of people don't realize is that the sun is continually throwing off this solar wind. It is continually expanding and bathing all of the planets. So even if it isn't a really big storm, we can still see the impact of space weather here on Earth because the solar wind is continually buffeting our planet. When we see the very big events, however, that lets a lot of energy into the Earth's magnetosphere and down into our atmosphere, causing it to glow. We think of that as the very beautiful northern and southern lights. That's a current system in the sky, and that can cause problems for power grids here on Earth, problems for spacecraft out in orbit, problems for astronauts, problems for GPS accuracy, lots and lots of impacts of space weather, all driven by the solar wind as predicted by Gene Parker.
So there's a lot of great reasons we should be going on this mission and exploring the sun. Yes, and what about, this has been 60 years in the making, right? So how has this mission evolved since then?
So it's kind of an interesting thing because we've had to wait for our technology to really catch up with what we want to do. And yet it's because we have so much technology here on Earth now that we rely on every day, we're now even more susceptible to the sun than we were 60 years ago. If you think 60 years ago, if you wanted to make a phone call, you had a rotary dial phone that was attached to a wall, and now you hold it in the palm of your hand with more technology than you can even believe. And so we've needed that leap in technology to be able to enable us to do this incredible mission.
That is definitely incredible. And what about you personally? You've been on this mission for 8 years now?
Yes, 8 years, and so it's been a long road, but it seems like it's gone by like that. It's just wonderful to work with this team, and it's incredible to be standing here today, looking at that Delta IV Heavy over there and waiting for it to take to the skies.
Will you be watching the launch with Dr. Parker himself?
I will be. I'm privileged. I will be standing right behind him, or as close to him as I can be, and I can't wait to see the look on his face when that Delta IV Heavy clears the pad.
Wonderful. Well, I have to say one of the things I've admired most about throughout this mission has been your incredible wardrobe. So.
Oh, today's rocket.
Yes.
Yes.
Well, we're definitely looking forward to this incredible launch. And with that, Marie, we'll go back to you.
All right. Thanks, Tori and Nikki. Let's go back to Franklin with more from heliophysicist Eric Christian. Franklin?
Thank you, Marie. Eric, during our first segment, we talked about the first question that Parker Solar Probe is going to answer, but there are actually 2 more. Tell us about them.
So one of the questions you saw a nice presentation from NASA on, and that's the coronal heating problem. Why is the corona so much hotter than the surface of the sun? Really strange. Parker Solar Probe is going to be in the region where the corona is still being heated, and so we can see exactly where that heat is coming from. The other question is, how is the solar wind, this stream of particles that blows out from the sun in all directions, how is that accelerated up to 1 million miles an hour? We don't know, and from Earth, the entire signature of the origin gets smeared out 93 million miles as it travels from the sun to the Earth. We need to be close to the sun in order to answer these basic questions.
Now, we were talking about the smearing that you were talking about just now, earlier today when we were doing our rollback segment, and you said that the solar winds from the sun can stretch as far as Pluto?
They go out way beyond Pluto, actually. The sun has blown a bubble in interstellar space that we call the heliosphere. It's what heliophysicists consider to be the solar system. Goes out beyond the orbit of Pluto, and we now have a spacecraft, Voyager 1, that for the first time has left that bubble. Everything inside that bubble is solar wind particles, solar wind magnetic field. Outside is interstellar space, the space in between the stars. So we have an interstellar probe now in Voyager 1. Hopefully Voyager 2 will be joining it soon.
Now, when we talk about solar weather, solar storms, you mentioned to me a story about Dr. Parker and how he looked at a comet and how solar weather affected the comet. Tell us about that.
So one of the interesting things about comets is the tails don't lead or follow the comet's movement. The comet tails always point away from the sun. And the only way that can happen if something is blowing off the sun faster than the comet is moving. And it was that clue that led Gene Parker to writing down the theory of the solar wind for the first time.
Now, when we talk about theories, do you have any that you are actually looking at when it comes to what Parker Solar Probe is actually going to find when it flies through the corona of the sun?
So there are several competing theories for all the questions that we're talking about, all three. I'll bet they're all wrong. Every time we've gone someplace new in the solar system, we've been surprised. I fully expect to be surprised by this mission. It's got great instruments. We're going to someplace that no one's ever been to before. We're going to learn something new, and that's the fun part of science.
Well, that's great to hear, and we definitely look forward to getting the data from the Parker Solar Probe. Dr. Christian, thanks for being with us today. Marie, back to you.
Thank you, Franklin. Parker Solar Probe will use its heat shield to protect itself against the sun. The shield is so robust, watch as engineers from Johns Hopkins Applied Physics Lab use a blowtorch to demonstrate how it works.
Is this natural?
Here we have a piece of the heat shield for Parker Solar Probe, which is a sandwich panel made of carbon that's like the graphite epoxy you might find in your golf clubs or your tennis rackets, some carbon foam, and then another piece of carbon on the back. It's very lightweight, as you can see. And here I've got a blowtorch, and I'm going to use it to get the front surface of this glowing hot, and then we'll have a nice demonstrator come in and touch the back with his hand. So let's get this started. You can start seeing it glowing red. The real heat shield gets up to about 2,500 degrees Fahrenheit, which we're not going to do today, but we are going to get it to a couple of 100 degrees Fahrenheit. So it's going pretty good now. Curtis, why don't you touch the back surface of that? What does it feel like? Nice and cool, he says. Which is just how we like it, keeping the spacecraft cool.
We are now just minutes from liftoff. Let's go over to the Mission Director Center for a live update from United Launch Alliance, and then Josh will take us through the count. Josh?
Thank you very much. I'm now joined by Alyssa Macbeth from United Launch Alliance. Welcome to the program, Alyssa.
Thank you for having me. It's great to be here.
And Alyssa, can you tell me a little bit about ULA and what it's been like to work on this Parker Solar Probe mission?
Yeah, so it's so exciting to always get to work on an interplanetary mission. It's a great opportunity for ULA to launch a rocket that will put the satellite in orbit to Venus and eventually to the sun. That's very exciting that we get to play a part in exploring the solar system.
And so I understand that you also brought a video with you that shows a little bit about the Delta IV after that T0 moment where it takes off through the flight. And show us the video?
Sure.
Sure.
2, 1, and liftoff. Liftoff of the United Launch Alliance Delta IV Heavy rocket.
3 Delta IV RS-68A main engines ignite and generate more than 2.1 million pounds of thrust to lift the rocket away from the pad. The Delta IV reaches Mach 1, the speed of sound, at 1 minute 18 seconds. At 3 minutes 56 seconds, the port and starboard booster engines shut down. 2 seconds later, the boosters are jettisoned. At 5 minutes 36 seconds, propellant levels deplete and the main engine shuts down. 7 seconds later, the Delta IV separation system activates to release the first stage. At 5 minutes 55 seconds, the first Delta cryogenic second stage, or DCSS main engine burn, begins. At approximately 6 minutes 5 seconds, the payload fairing is jettisoned. At 10 minutes 37 seconds, cutoff of the DCSS engine, or MECO 1, occurs. At 22 minutes 25 seconds, the DCSS main engine is restarted for the second burn. Approximately 14 minutes later, second cutoff of the DCSS main engine occurs. Following a 30-second coast phase, the third stage is separated. 20 seconds later, the third stage is ignited. Approximately 1 minute 29 seconds later, burnout of the third stage solid rocket motor occurs. At 43 minutes 10 seconds, the third stage releases NASA's Parker Solar Probe spacecraft on its journey to the Sun.
So it looks like it gets pretty exciting at T0 for the Delta IV Heavy with the additional third stage. So you're often on console for United Launch Alliance missions, and can you characterize what it's like to sit on console during a mission?
Yes, definitely. So overall, it's very exciting to be on console. But at this point, we have prepared and planned and spent so much time up until this point that we're just ready to go at this point. So what else is cool about United Launch Alliance is that we have a team of people at the launch site as well as in Denver, our headquarters, that are supporting on console. So these are the systems engineers who are experts in launching rockets. And they have gotten to this point where they are, they know everything to the minute detail of what's going on. And like I said, we're just ready to go, and we're excited to be a part of it.
And so can you tell me what's happened up to this point in the countdown and what we can expect before launch?
Yeah, so we're about to enter into hold in a couple minutes here. So at this point, the rocket is fully fueled. There are a team of engineers who have performed some testing, final testing on the avionics systems, and at this point we are not working anything but getting ready for that final pull before we head into the terminal count.
So United Launch Alliance has facilities all over the U.S. Can you talk more about ULA as a whole and what they've put forward to design, build, and launch this Parker Solar Probe mission, and how do the teams company-wide work?
Yeah, definitely. So it takes a large group of people, exemplary people, to get where we are at this point. So we have design engineers who brilliantly produce and develop a rocket, and then the production sites in Alabama and Texas provide a perfect product to the launch site where we put it all together and do the final installations and hookups to prepare for launch. Teamwork is a standard at ULA. There's no doubt about it that we hold that to a high degree, and we wouldn't be United Launch Alliance without that team. So all the sites are working together and to get us to this point.
And for those of you that are just joining us, I'm sitting here with Alyssa Macbeth of United Launch Alliance, and we're inside of the T-minus 4-minute hold. This is a 20-minute hold, so on our launch clock, we're about 11 minutes, 40 seconds and counting. On your screen, you're looking at a live shot of the Delta IV at Space Launch Complex 37, which is the East Coast home for the Delta IV Heavy rocket. Alyssa, can you explain to me why this mission is so significant to United Launch Alliance?
Yeah, so this is actually our 6th launch of this year. It's our 129th successful launch as ULA since we formed in 2006. As you said, there are 3 stages with this specific payload, and the energy required is something that only our vehicle can do. It's the only rocket out there that can do what Parker Solar Probe needs it to do. So it's definitely significant in terms of performance of our rocket. We get to kind of show off here a little bit and show the world what ULA can do.
And again, on your screen, another shot of the United Launch Alliance Delta IV Heavy rocket at Space Launch Complex 37. Behind it, you see the mobile service tower, which is used to, it provides an access point for the rocket. Can you tell us a little bit more about what the mobile service tower does when it's around the rocket?
Yeah, so the mobile service tower provides 360-degree access. So any part of the rocket that you would need to get to in order to install avionics boxes, or get to the engines, or install ordnance. That mobile service tower provides that access to do that. And then at T0, that access goes away. So you can see you have the mobile service tower. Well, it's called the fixed umbilical tower there, and those arms will swing away as the rocket lifts off.
So we're at an L minus 10 minutes, and counting on the L clock, the T clock is still stopped at the T minus 4-minute mark before we launch NASA's Parker Solar Probe. NASA's Parker Solar Probe will determine the structure and dynamics of the sun's coronal magnetic field. It'll understand how the solar corona and wind are heated and accelerated, and determine what mechanism accelerate and transport energetic particles. That was United Launch Alliance indicating how to indicate a hold in the count, although we're still marching toward a liftoff at 3:53 a.m. Eastern Time. We are inside of a T-minus 4-minute hold.
Verify the whole fire switch is in the proceed position.
Ready to proceed.
RLM, verify red line monitor and event table are in the correct configuration for terminal count.
Verified.
You are still looking at a live shot there of the base of the Delta IV rocket. And Alyssa, can you tell me a little bit more about the Delta IV?
Yeah, so the Delta IV stands at approximately 233 feet tall with a 5-meter payload fairing. Its first launch was December 21st in 2004 and has had successful launches since then. It is fully capable of launching up to 14,000 pounds of payload, and it has a unique ability with its second stage to deliver a payload anywhere it needs to go in the solar system, including the sun.
And we're sitting about a minute out from one of our polls. Can you tell us a little bit about what's coming up at the L-7 mark?
Yeah, L-7, like I said, we're in a point where we've reached all of our milestones throughout the countdown, and we're getting ready to pull, which is basically a go from each of our systems engineers to say that their systems are ready for launch. So the launch conductor will go through the list of engineers, they will respond with a go, and that is an indication that the launch is ready and the Delta Heavy is ready to fly.
So we're about 30 seconds from the poll that Alyssa Macbeth of United Launch Alliance was just talking about. On your screen, you see the Delta IV Heavy rocket poised for liftoff at 3:53 a.m. 15 seconds before the poll.
Status check to proceed with terminal count. First stage system, propulsion.
Go.
Hydraulics.
Go.
Locks.
Go.
LH2.
Go.
Second stage systems, locks.
Go.
LH2.
Go.
Third stage systems, third stage vehicle manager. Go. Electrical systems, airborne.
Go.
Ground.
Go.
Facility. RFFTS.
Go.
Flight control.
Go.
COM.
Go.
GCQ.
Go.
Operation support.
No go pending the resolution of the TISR anomaly just briefed on 6.
Roger. Pneumatics.
Go.
Umbilicals.
Go.
Gas.
Go.
ACS.
Go.
Red line monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
No go VME status.
Roger. Anomaly chief.
No go. VME status.
Roger. Range coordinator.
Clear to proceed.
Roger. LD, LC.
LD on 1.
Yeah, we have a no-go conditions going to not ready with your direction.
Roger.
LC switch not ready. AC, please inform me of the not ready condition.
We will get you a report as soon as possible.
Roger.
And as you just heard, that was the poll done at the L-7 mark. And as you heard on the countdown, that we're right now in a no-go status. We'll stand by for more information.
Okay, all personnel in Net 1, all console operators maintain system readiness. Allow the anomaly team to investigate the condition and be ready for a new T0 coordination.
If you're just joining us, you see that the clocks are at L-4 minutes, T-4 minutes during the terminal count readiness poll that would allow us to exit the T-4 minute hold. We had a condition which the teams are looking into as we speak, and so we'll look to establish a new T0 at a time coming up. Mick and I will continue to monitor the situation here from the Mission Director Center, and we'll bring you more as we know. We're here in the Mission Director Center monitoring as launch teams continue to work toward a liftoff time. Mick, can you tell me what the launch teams are working on?
Yeah, the teams right now are, in the T-4 holding. You heard the poll for the no-go situation that they're doing. And so the teams are taking this chance while the assessment is being done to evaluate what's going on. The other parts of the team are taking a look at the rocket and just verifying that all other aspects of the vehicle are still within specifications and ready to proceed forward with the T0 tonight. So as the EGSE team takes a look at what's going on, they'll get back to the launch director and launch conductor to let them know their resolution, and we'll look forward for a new T0 as we continue to hold here at T-4, using up some of the window that's still available. Right now we have 39 minutes left in the launch availability window for this evening's launch.
So you're looking at a live shot of the Delta IV Heavy with the additional third stage on your screen there. Mick and I will continue to monitor the count, and we'll bring you updates as we know it. You are looking at a live shot of the Delta IV Heavy rocket at Space Launch Complex 37 on Cape Canaveral Air Force Station. On the bottom of the right of your screen, you see the T clock, which is stopped at the T-minus 4-minute mark. Mick, can you tell us a little bit about the clocks?
Yeah, the T clock is used by the team to continue working through the launch procedure. We also have an L clock, which has the built-in hold times. Of course, we're at the T-4 and holding point right now, so there's no more hold time remaining. So we're actually in this hold pattern using up some of our available launch window this evening. We had 45 minutes left over in our launch window. We're down to 35 minutes in that launch available window right now as teams continue to work through the issues that they've identified during the last poll before moving into terminal count. You know, it's been a very busy morning for us here, starting with tower roll all the way through fueling. There have been a lot of things the team has been working, and they continue to work diligently through this issue as they want to assess and make sure everything is in perfect order before moving into the terminal count for a on-time liftoff later this morning.
So while the T clock holds at the T-4 mark, we'll continue to monitor the launch teams, and we'll bring you more updates. From Delta Launch Control, we're at the T-minus 4-minute mark and holding. On your screen you see the Delta IV there, the Delta IV Heavy with the additional third stage. Teams are continuing to work. Although the T clock is stopped, and we'll bring you more information as we know it for the launch of NASA's Parker Solar Probe. The Parker Solar Probe's observations from directly inside the corona will help scientists understand why the Sun's atmosphere is some 1,000 times hotter than its surface. The mission will provide unprecedentedly close observations of the solar wind, the constant outflow of solar material hurled from the Sun at 1 million miles per hour. NASA's Parker Solar Probe will also study how solar eruptions accelerate particles to such energies that they can pose a hazardous condition for astronauts and technology in space. Understanding more about the fundamental processes near the Sun will provide key information to better understand their effects on the space environment near Earth, such as space weather can damage the orbits of satellites, shorten their lifetimes, or interfere with onboard electronics. The more we learn about what causes space weather and how to predict it, the better we can protect the satellites we depend on. Understanding more about space weather also helps protect astronauts from dangerous radiation exposure during potential human spaceflight missions exploring the Moon and Mars. The Sun is the only star that can be studied up close. Observing the star we live near sheds light on stars throughout the universe. Parker Solar Probe is the newest addition to NASA's heliophysics fleet. Missions that study the vast interconnected system from the Sun to the space surrounding Earth and other planets to the farthest limits of the Sun's constantly flowing streams of solar wind. Parker Solar Probe provides key information about how the Sun drives this dynamic and complex system.
LC1 is ACM ready to outbrief the VME disable hit.
Roger. LD net 1.
LD.
NLM net 1.
NLM.
Proceed, AC.
Okay, this occurred about a minute after the expected response from the ground PSM stream. This is from the vehicle. The team has evaluated the data. We recognize that it was from the vehicle. The streams are good, and we are in a good position to proceed. The risk level is the same as what we had discussed previously and voted to proceed. So the anomaly team is recommending we try again.
LC concurs. LD.
LD concurs.
NLM.
NLM concurs.
And you're looking at a live shot of the Delta IV Heavy at Space Launch Complex 37. If you're just joining us, we are at T-4 and holding. We started tonight with a 65-minute window. We now are down to 23 minutes. But Mick, can you tell us a little bit about what we just heard on Countdown 1?
Yeah, absolutely. The team evaluated the vehicle from the no-go situation they had in the T-4 poll a little earlier. What they were working on was a ground data stream that comes from the launch vehicle back to the computers in the control center. And the team looked at that data hit that they had gotten and have determined that they completely understand it, and the data stream has returned to its normal operation. And the level of comfort is good, and they are ready to proceed forward as they reported to the launch conductor.
Roger. 08:28:000. RC. LC.
RCN1.
Please coordinate a new T00828.
Roger and work.
ALC, please set the clock for 0828.
Roger.
OVM, LC net 1.
Go LC.
New target T0082800.
Copy. Target 082800. We'll proceed into checklist A.
Roger.
LC clock has been set for new T0 of 0828. We're at approximately L60.
Roger.
And from Delta Launch Control, I'm Josh, and I'm joined with Mick Woltman from NASA's Launch Service Program, and we just heard a countdown from the launch teams. Can you characterize
LC,
what that
RC,
update was?
Yes, Josh.
Yeah,
what the team was doing is, we were talking a little earlier, the team evaluated the ground data stream from the launch vehicle. They've determined they are good to proceed with launch this evening. So NASA's launch manager, Omar Baez, and United Launch Alliance's launch director, Lou Mangiuri, have coordinated a new T0 time this morning for 4:28 a.m. That's approximately 16 minutes from now to get Parker Solar Probe on its way towards the sun. So we're hoping for a smooth liftoff this evening as the teams continue to work forward and through the count procedure and get ready to pick up the count coming out of the T-4 hold.
And so we'll pick up that count in just over 10 minutes.
I believe that is correct.
Bellman, it's 14 minutes. LCOVM.
Go OVM.
Third stage recycle checklist A is complete. We're on external power.
Roger.
From Delta Launch Control, you're looking at a live view of the Delta IV Heavy rocket with the additional third stage at Space Launch Complex 37 on Cape Canaveral Air Force Station. I'm Josh, and I'm joined by Mick Woltman of NASA's Launch Services Program. We've coordinated a new T0 for 4:28 a.m., which will leave about 10 minutes left in our window. And Mick, can you tell me, now that we've reset the clock to about L-12 minutes, what we can expect?
Yeah, as we move forward from here, the launch teams will continue to work through their procedure, stepping through all aspects of the Delta IV launch vehicle. And as they get ready to enter into the terminal count, what we will see is the launch teams prepping the FTS system and getting it armed and ready to go. We'll see the third stage enter onto internal power as they perform their testing and get ready for launch. And then the Delta launch vehicle, second stage and first stage, will also enter onto internal power and getting ready for those final few minutes prior to liftoff this morning. And then about just prior to liftoff, we'll have the RS-68 engines being purged with a hydrogen purge that's going through there, and that will fill up around the engines and create some pockets around the Delta IV Heavy launch vehicle. Once the RS-68 engine ignites, it'll actually look like the Delta IV Heavy is engulfed in flames a little bit, but that's actually normal for a Delta IV Heavy launch vehicle because of that hydrogen purge that started prior to launch, and that all catches in the ignition of the RS-68. So the team will be very busy in those last 4 minutes prepping for the count and moving forward towards a liftoff at 4:28 this morning.
And can you tell us a little bit more about the Delta IV Heavy that we're looking at on our screen?
Yeah, absolutely. As we talked a little earlier, this particular Delta IV Heavy for Parker Solar Probe has 3 common booster cores, each with an RS-68 engine, which is a hydrogen-fueled engine that provides the thrust to get out of Earth's atmosphere. Sitting on top of the center core is a Delta cryogenic second stage, which is powered by an RL-10B engine, which will provide that intermediate escape velocity for the Parker Solar Probe mission once it's in space. Moving up the stack, you have the 5-meter fairing, which is encompassing Parker Solar Probe, and the mission unique third stage that was provided by Northrop Grumman Innovation Systems, a Star 48 BV motor. It's a vectorable motor that once in space, the Star 48 will provide that last little push for Parker Solar Probe to get into its trajectory heading towards the sun. Another unique thing, and we keep talking about this being a historic mission today, Josh. It is a very historic mission of getting Parker Solar Probe onto the sun, as this has been thought about for the last 60 years to get out and study the sun. But for some of our viewing audience, Launch Complex 37 is also a historic launch pad. Back in the 1960s, it was used as part of the Apollo program, launching Saturn 1s and Saturn 1Bs. It was also the place where we launched the first unmanned lunar module from. And then ULA acquired Launch Complex 37 in 2001 and began their program of Delta IV launches from here. So it's a historic launch all the way around for United Launch Alliance and NASA this evening.
And so for tonight, it'll launch NASA's Parker Solar Probe, which will make repeated journeys into the sun's corona and trace the flow of energy to answer fundamental questions such as why the solar atmosphere is dramatically hotter than the sun's surface, what accelerates the solar wind that blows outward through the solar system, and what is the source of this high-energy solar particles. Parker Solar Probe will make 24 elliptical orbits of the sun and even use 7 Venus flybys to shrink the orbit closer to the sun during the 7-year mission. The probe will fly 7 times closer to the sun than any spacecraft before, a mere 3.9 million miles above the surface, which is about 4% of the distance from the sun to the Earth. At the closest approach, Parker Solar Probe will reach a top speed of 430,000 miles per hour, or 120 miles per hour per second, making it the fastest spacecraft in history. We're just about a minute from our status check for continuing the count. We're at T-4 and holding.
Status check to proceed with terminal count. First stage systems, propulsion. Go. Hydraulics.
Go.
Locks.
Go.
LH2.
Go.
Second stage systems, locks.
Go.
LH2.
Go.
Third stage systems, third stage vehicle manager.
Go.
Electrical systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
Com. Com.
Com is go.
GCQ.
Go.
Operations support.
Go.
Pneumatics.
Go.
Umbilicals.
Go.
Haz gas.
Go.
ACS.
Go.
Red light monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
Relay safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
Go.
Range coordinator.
Clear to proceed.
Launch director.
You have permission to launch.
Proceeding with the count. MEQ established, swing arm lock, pins pulled.
Active.
From Delta Launch Control, you just heard the terminal count readiness poll with permission to continue the count. I'm joined by Mick Woltman of NASA's Launch Service Program. Mick, can you get us up to speed on where we are tonight?
Yes, for those just tuning in, we're getting ready to come out of the T-4 hold with a new T0 of 4:28 a.m. this morning. The T clock had stopped at T-4, giving the team time to work through the EGSE issue that they had identified earlier in the count. The T clock, as we like to refer, is the official countdown clock. It had stopped at the T-4 mark and held there for some minutes to allow the team to assess the health of the Delta IV launch vehicle as we proceed forward with the launch tonight till 4:28 a.m.
OVM transfer, third stage.
Launch teams have finished topping the vehicle, fueled the first and second stage. All systems look like they are ready to go. As we just heard the poll from the team, everyone is go to pick up the terminal count and begin transferring to internal power and final checks, heading towards a successful liftoff at 4:28 this morning.
We're just about 20 seconds away from picking up the count.
And we are getting ready to come out of the hold in 3, 2, 1. We are T-4 and counting.
3:55. Ground pyros enabled.
We are at T-3 minutes, 35 seconds and counting. Coming up at the 2.5 minute mark before launch, the launch conductor will ask the NASA spacecraft coordinator to verify that the spacecraft is on internal power.
Minus 325.
About 15 seconds later, NASA launch manager Omar Baez will give Lou Mangieri of United Launch Alliance, he's the launch director, the NASA go or no-go for launch. About 1 minute before liftoff, the launch conductor will ask the range operations coordinator, or ROC. You'll hear the status for ROC to report range. At T-0, the United Launch Alliance Delta IV Heavy will lift off from Space Launch Complex 37. The Delta IV Heavy begins flying on its planned trajectory, and just under 45 minutes later, NASA's Parker Solar Probe will separate from the third stage, beginning its mission to study the Sun.
FTS internal.
You just heard the call for the flight termination system to go internal. From now, we'll be listening to the launch teams live from the Delta Operations Center.
Flight pressure and flight level.
As we enter in the final minutes of the countdown, we'll listen in to the...
NSC verifies spacecraft on internal power.
We'll listen to the launch teams count down into the final minutes of the count. And then NASA's Parker Solar Probe is verified to be on internal power. After launch, we'll hear the voice of United Launch Alliance, Patrick Moore, giving real live telemetry of the Delta IV performance.
T-minus 2 minutes.
Hydraulic press at 4,000.
Vehicle internal.
Hold. This is RLM. And what LC is not ready. All personnel, go to race cycle pages, operation 90.
Okay, LC was a GH helium regulator inlet press.
Roger. Okay, team, we held it T-minus 1 minute 55 seconds.
From Delta Launch Control, we are holding at the T-minus 1 minute 55 second mark in the count. We have 9 minutes and 15 seconds remaining in tonight's window.
Flight control, you ready to reset the clock T4 and holding?
Flight control is ready for that.
Roger. ALC, reset the countdown clock T-minus 4 minutes and holding.
Roger.
PLE, evaluate LOX recycle and report if ready to restart LOX pumps.
Roger. LC,
Pumps are running.
LC flight control, SFAP's inactive, STS in pre-flight mode.
Roger.
LC countdown clock has been reset to T-minus 4 minutes and holding.
Roger. OSM, place SRM ignition switch at disabled position.
SRM is at disable.
OVM, perform third stage recycle checklist.
LC, are we going again tonight?
We're past T-minus 2 minutes negative.
Copy that. At this point, we'll proceed to our power down checklist.
Roger. LD, LC net 1.
LD on 1.
All right, LD with our scrub past L minus, or excuse me, our hold past T-minus 2 minutes. You need to recycle back to L minus 4 minutes. Window will not support that second attempt.
That is correct, so let's set up for 24-hour recycle.
Roger. ALC on TC emergency panel, high-speed cameras normal.
Normal.
From Delta Launch Control, as you just heard on the live countdown net, we have expired our time in our window for tonight's
All
launch.
stations recycle systems back to T-minus 4 and holding
So we'll begin
configuration.
to recycle and
occurred
go
at
for a
T-minus
24-hour
1:55.
turnaround time
Report
for the launch
status
of
at
NASA's
completion.
Parker Solar Probe. Mick and I, who are monitoring the countdown in the Launch Control Center,
That'll be operation.
will continue to
97.
monitor and bring you more information as we know it.
LCHWA.
Go H-way.
Step 230, substep delta, hydraulic system stable.
Roger.
LC PNE.
Go PNE.
Substep alpha, pneumatic pressure stable.
Roger.
LC ECS.
Go.
Substep November, ECS set point stable.
Roger.
LC FTS, substep Juliet, FTS safe and external.
Roger.
LC prop 1.
Go prop 1.
Substep Charlie, RS-68 propulsion system stable.
Roger.
LC Fuel 2.
Go.
First substep Hotel, second stage LH2 conditioning is complete.
Roger.
LC SYS.
Go SY.
Substep Lima, GC Cube ready.
Roger.
LCMEQ.
Go.
Substeps Foxtrot and Oscar, Hasgas, TSM, and swing arm systems ready.
Roger.
LC flight control.
Go.
Substep Kilo, flight controls ready.
Roger.
LCAB.
Go.
First up, AB airboats is vehicle external.
Roger.
LCOVM.
Go.
Third stage power down checklist is complete.
Roger. And OVM, you're on external power?
We're completely powered down.
Oh, roger that.
LC LOX 2.
Go.
Second stage LO2 conditioning active.
Roger.
LC Fuel 1.
Go.
CBC LH2 topping and conditioning are active.
Roger.
LCG on.
Go.
Yeah. Pistons ready.
Roger.
Copy going in.
From Delta Launch Control, we have scrubbed for tonight's attempt, which was targeted to go at 3:53, but we expired our time in the window. Mick, can you tell us a little more?
Yeah, absolutely, Josh. Teams worked very hard this evening, diligently getting through the launch process, looking at everything that they had to get into the terminal count this evening. As we picked up the count at T-4 and got into terminal count, the team received a gaseous helium reg pressure alarm that kicked them out. That was what you heard the hold on the countdown net was for. The team is evaluating that and looking at it. Unfortunately, we didn't have enough time this evening to go troubleshoot that and try again for a launch. So we're going to lean forward here and plan for a 24-hour turnaround tomorrow for a launch time of 3:31 a.m. However, that is contingent upon the detanking process this evening and the team continuing their evaluation of the gaseous helium reg alarm. If they determine or find anything that they can't get ready for tomorrow's launch attempt, the launch management team will get together and determine if we maintain that 24-hour turnaround or if we go to a 48-hour turnaround. So that's where we are right now. Unfortunately, we did scrub this evening due to this issue, but the teams will continue to work this problem and move forward to try to get Parker Solar Probe on its way to the sun.
Thank you, Mick, for the update. And with that update, we'll now go back to Marie Lewis. Marie?
All right. Josh and Mick, thank you so much for keeping us updated. As you just heard, today's launch attempt has been scrubbed, and this concludes our coverage of today's Parker Solar Probe launch attempt. For updates on the next attempt and the Parker mission, visit nasa.gov. Thank you for getting up so early with us, and we invite you to rejoin us when we try again. Have a great day.